We have looked at the theory of spectral power spectral factorization and power spectral representation. Now let us have a couple of simple examples. So assume that the power spectrum is given by this function. Obviously we can plot this one. If omega is equal to 0, denominator is minimum, so therefore the power spectrum is the highest, so you get n over alpha 2. And if omega goes to either plus infinity or minus infinity, this power spectrum becomes 0, so you get Cauchy-Bell function, something like that, so asymptotically becomes 0. So this is a low pass one sensitization random process if alpha is a positive number. So so what we can do is to immediately we have s x of omega equal to n divided by alpha 2 plus omega 2. So the first thing I need to do is to take these omega 2 here, this omega 2 out, and replace it by minus s2. Okay, so I do that and I replace it minus s2 becomes minus s2, and then this function becomes s x of s. Now I have to determine the poles, so n equals 0, n is a number, has no solution. Because a real number cannot be equal to 0, so no zeros. So this power spectrum has no zeros. And then I have alpha 2 minus s2 equals 0. So from here I get s1 and 2 is equal to plus minus alpha. So what I put here, so I have no zero, so I don't put any circle here, and at point alpha I have one pole. At point minus alpha also I have. So that means that this function at these two poles, this function becomes infinity, very large. So what I could do is to, from here I could see that this xx of alpha 2 minus s2 can be written as alpha minus s times alpha plus s, which is like, this is if you solve this equal to 0, you get one of the poles. If you solve this, you get. So you could see that as xx of s, because you have n, I write it a square root of n, and then divided by alpha minus s, and a square root of n divided by alpha plus s. So one of these two functions is equal to L of s, the other one is equal to L of minus 1. So which one is the minimum phase? The one which has this pole is minimum phase. So this is L of s. So from here you get that your L of s is given by this filter, and this is a representation of a first order low pass filter. Another example, suppose that we want to find the power spectral factorization of this random process. I go over the same steps. I take omega 2 and I replace it by s2, so I get s x of s becomes equal to 49 plus 25, and this plus becomes minus. Times minus s2, and then I get 1 instead of plus omega 2 becomes minus s2. and then omega 4 becomes S4, and then minus 10 times S2, and then plus 9. Now I have to find the zeros. For zeros, I say 49 minus 25 S2 equals 0. I find a solution. I get S1 and 2, two solutions, is equal to plus minus 7 divided by 5. For these are zeros. For poles, I solve the numerator. So 1 minus S2 times S4 minus 10 S2 plus 9 equals 0. So from here you get 1 minus S2 is equal to 0, or either this term is 0 or the second term, or S4 minus 10 S2 plus 9 is equal to 0. So the first one gives S equal to S1 and S2 is equal to plus minus 1. So you get two poles at plus 1 minus 1. And the second one, so the second equation is second order polynomial in terms of S2. So you get S2 equal to, so you know how to solve second order polynomial. So you could replace S2 by X, and then you get X to the power of 2 minus 10X plus 9, and remember that X is equal to S2. So first you solve this equation, you find a solution for X, and then replace X by S2, and then you get two new equations of second order, and you solve them separately, and then you get four poles. So once you do that, you could decompose this function by 2 zeros and then 6 poles. So now we have to determine which poles are for LS, which zeros are for LS. So what I see here is that this one has a negative real part for S. This one has positive real part. This one has a positive real part. So I have to get this one for LS because negative, and this one. So L of S for me is equal to 7 plus 5S divided by 1 plus S to the power of 2, and then 3 plus S. And L of minus S obviously is equal to 7 minus 5S, and then 1 minus S to the power of 2, and then 3 minus S. So remember that if you replace S by minus S, you get this one, and if you multiply them together, you get this function. So the problem is solved. So this is your final solution. Obviously, the inverse of this filter, you could change the place of numerator and denominator.